And we have yet another problem. और इस प्रॉब्लम की खासियत ये है कि I still don't know, but I knew very bright students in my lifetime. And every one of them asked this problem one in another way. So I would like to solve this problem. There is a very simple thought involved in this problem. The problem is two rigid bodies rotate around fixed, mutually perpendicular intersecting axes. You can draw a diagram in your mind with constant angular velocities omega 1 and omega 2. So they both are rotating frame of reference, rotating with constant angular velocities on mutually perpendicular axes. Find the angular velocity and angular acceleration of one body relative to the other. Relative angular velocity and angular acceleration. They always wanted to come looking for some type of theory, but I never had one. So I can draw a diagram of two mutually perpendicular vectors, because angular velocities are in the direction of axis about which the bodies are rotating. So these are two vectors. I got two vectors, omega 1 and omega 2, and both are perpendicular. I know, because both the bodies are rotating about their perpendicular axis. So if axes are perpendicular and angular velocities are along the axis of rotation, so their angular velocities are perpendicular. That means I got two vectors, and I need to find out relative velocity of one with respect to 2. So this is the one, omega 2 minus omega 1, because omega 1 plus this vector is equal to omega 2. So you can get here, this is the relative acceleration vector, this thing. This is the relative velocity x vector. And what about its magnitude? The magnitude of relative velocity vector is, of course, the root omega 1 square plus omega 2 square. That's simple. We got two vectors. Now we want to know the relative acceleration. Then in this case, the relative acceleration, I would like to write it beta or alpha, whatever you whatever symbol you would like to say, to give them, just give it. So beta is simply the derivative of relative velocity with respect to time. It's a derivative. I'm not saying it as a vector, I'm saying it as a derivative. So this is d omega 2 minus omega 1. This is omega 2 minus omega 1. मेरा दिमाग खराब है. Upon dt, and this is the angular acceleration you are looking for. And this is omega 2 by d omega 2 by dt minus d omega 1 upon dt. This is our relative acceleration, and then I'm going to forget these physical quantities for some time. I'm focusing myself on vector. So this is the relative velocity, relative acceleration I'm looking for, and this is the relative velocity of second rigid body with respect to first one. So the first one is at rest basically. Omega vector omega 2 minus omega 1 is the relative velocity of body 2 with respect to rotating body 1. So observer is always at rest. That means in this case, this is the observer is sitting here somewhere on this axis along the omega 1 vector. So for this observer, for this observer sitting on the vector omega 1, d omega 1 by dt is equal to 0, because it is constant in both in magnitude and direction. So what I'm going to write, that for our observer d omega 1 by dt is equal to 0. Nothing changes with respect to the observer itself. An observer is always at rest with respect to itself. Don't forget it. So I don't need to explain anything about it. D omega 1 by dt is always equal to 0. So it is 0. What about d omega 2 by dt? So our observer is at rest. तो ये हमारा ऑब्जर्वर है जो कि रेस्ट में है. ऑब्जर्वर को छोड़ो ना. दिस इज ए वेक्टर and this is another vector, and since this was originally rotating with respect to the ground, originally rotating with angular velocity omega 1, and this is rotating like this in this direction. But अगर मैं इसको रेस्ट में मान लूँ, if मैं इसी पे बैठ जाऊँ, if this observer is at rest, this rotating observer को ही रेस्ट में मान लूँ, तो that means this arrow is rotating in a circle like this, इसका अपोजिट डायरेक्शन में ऐसे. मतलब ये खुद एंटी क्लॉकवाइज डायरेक्शन में रोटेट कर रहा, तो ये क्लॉकवाइज डायरेक्शन में ऐसे रोटेट करना, का डायरेक्शन से यहाँ कोई लेना देना नहीं है. इट स्टार्टेड फॉर दिस ऑब्जर्वर, दिस एरो इज रोटेटिंग इन अ सर्कल. तो ये ओमेगा 2 वेक्टर इज दैट एरो दैट इज रोटेटिंग with a constant. This vector omega 2, I know a vector A that is rotating in a certain frame with constant angular velocity. Then its derivative is simply written as magnitude of vector A d theta by dt. I know this thing from circular motion. What is V equals omega r or something like that. तो ये कांस्टेंट रेडियस के सर्किल में रोटेट कर रहा है, तो इसका रेडियस तो इसका लेंथ ही हो गया. सो आई वांट टू नो डी ओमेगा 2 बाई डी टी इन दिस फ्रेम, because in this frame d omega 1 by dt is equal to 0. So I want to find the d omega t2 by dt, magnitude of d omega 2 by dt in this frame. And so I want to find the derivative of this vector omega 2. So it will be equal to magnitude of omega 1 multiplied by the angular velocity with which this arrow is rotating, and that is omega 1. ये खुद ऐसे रोटेट करता, तो उसके रिस्पेक्ट में ये उसका उल्टा रोटेट करेगा, omega 1. So its magnitude is omega 2 multiplied by omega 1, and you got the value magnitude of d omega by dt, and we solved this problem as well. There is nothing else to solve now. So the answer, I found the answer. You watch this video again. What I'm telling you. मैंने क्या बोला कि अगर मेरे पास एक वेक्टर है, इस वेक्टर का मैग्नीट्यूड कांस्टेंट है, बट its direction is changing at a constant rate. d theta by dt is constant, say omega, and it's a constant. But take this x-axis, take this y-axis, and you simply write vector A equals A cos theta I cap plus A sin theta j cap, and write this A cos theta I cap plus sin theta j cap. Now find dA vector upon dt. So इसमें what is the constant and what is the variable you need to find out. So A is a constant, magnitude है A का, that is a constant here. This is simply the magnitude of vector A, and this is a constant. So it will come out of the differentiation sign as well. I and j also are not rotating. In this case only this arrow of vector A is rotating, so theta is changing. So we all know the differentiation of cos theta with respect to time is टाइम इज एक स्टेप आगे सोचने का बीमारी है. Differentiation of cos theta with respect to time is minus sin theta d theta by dt, and I cap is again constant, and we could do the write the derivative of sin theta with respect to time, and this becomes cos theta d theta by dt j cap. So you got here a d theta by dt minus sin theta I cap plus cos theta j cap, and so this is a omega, and this is a vector, denotes the direction of dA by dt का डायरेक्शन के इसके डायरेक्शन में यूनिट वेक्टर है. सो मैग्नीट्यूड ऑफ dA by dt is this a omega simply. So a omega or a d theta by dt. So what was that was written previously, that was used, and I have solved the problem. Thank you very much.